Hi, today we are going to talk about the spermatogenesis versus oogenesis and the different processes in which they are included. To begin this topic, we are going to discuss about spermatogenesis. This is the production of sperm. The process first begins by meiotic division of a primary spermatocyte resulting in two secondary spermatocytes. The second division produces 4 haploid spermatids, which will become a sperm. Spermatogenesis is highly dependent upon optimal conditions for the process to occur correctly, and is essential for sexual reproduction. DNA methylation and histone modification have been implicated in the regulation of this process. It starts at puberty and usually continues uninterrupted until death, although a slight decrease can be discerned in the quantity of the produced sperm with increase in age. The process of spermatogenesis is more easily explained on the chart behind me. The seminiferous tubules producing sperm is the concept of spermatogenesis. The first step begins by meiosis, during which the number of chromosomes in the cell are reduced by half, or 23 chromosomes. Next step is meiosis II, during which each haploid cell forms spermatids. Last step includes each spermatid developing into a sperm cells with a head and tail. The next topic that we are going to discuss is the process of oogenesis. This process occurs in meiosis as well, but with some modifications. It is the process of producing female gametes, once sex determination of the embryo has occurred. Oogenesis creates egg cells, known as the ova, and is completed throughout a woman's lifetime. Like spermatogenesis, oogenesis involves the creation of haploid sex cells through the process of meiosis. Now I'm going to explain oogenesis in more of a step-by-step process. A primary oocyte immediately begins in prophase 1 of meiosis. Here, development stops in many species. The primary oocyte grows larger and acquires nutrients. When meiosis resumes, the nucleus of the oocyte divides into 2 daughter cells of unequal sizes. The second meiotic division forms daughter cells of unequal sizes. On is the large oocyte, which becomes a mature ovum. When oogenesis is complete, female gametes will have been produced. This leaves the products of oogenesis to wait until fertilization will occur, or in other words, until the sperm produced by spermatogenesis fuses the female gametes' egg cells. Now I'm going to give you a short overview of the overall topic that we just covered. Meiosis, the process by which gametes are formed, can also be called gametogenesis, literally creation of gametes. Remember that spermatogenesis produces sperms while oogenesis produces female gametes' egg cells. The most important thing that you have to remember is that both of these processes take place in meiosis and that they differ slightly. Okay, now I'm going to give you a small oral review quiz. First question is, what are products of spermatogenesis and oogenesis? If you answered sperms on spermatogenesis and egg cells on oogenesis, then you are correct. The second question is, where does these two processes occur? If you answers the question with meiosis, then you are correct. The last question includes paragraph answer. Explain the steps in these two processes. This was my presentation to you about the processes of spermatogenesis and oogenesis. I hope that it helped you to understand at least the basic concept of these two processes and that you will be able to explain this topic well for others.